protons and the neutrons make up the mass number. And usually you can see these in what part of the atom? They're found in where? The nucleus. Now this differentiates from the nucleus of a living cell. The nucleus of an atom has the protons and the neutrons, which gives you the mass number. In a living cell, what does the nucleus have? The nucleus of a living cell contains the DNA. Regular cell consists of DNA in the nucleus. In an atom, it's a mass number. It's just like carbon. Sometimes you see carbon written like this, carbon 12. This bottom number tells you what's in the nucleus. This is a mass number. And it's the sum of the protons and the neutrons. Now, this number at the top here gives you a lot of information. Number one, it tells you how many electrons it has. This number here is always the same as the number of electrons that it has. The number of protons. The number of protons is equal to the number of electrons in an atom. Okay. Because the atom is usually electrically neutral. Two charges transfer to each other. Protons have positive charge and the electrons have negative charge. You see, positively charged, negatively charged. Cancel each other. So let's look at electrons. Now, electrons are the subatomic particles that are shifted around, causing the atom to become what? An ion. When an atom loses electrons, it becomes what? A positive ion. An ion is a positively charged particle. It could either be positive or an ion is a charged particle period. It could either be positively charged or negatively charged. A positively charged ion is one that has what? More protons than electrons. Or you put it the other way, less electrons than protons. More positive charge than negative charge makes it positive. Okay? A negative ion has more electrons than protons, or less protons than electrons. Now the protons, the number of protons is unique to each atom or element. What do I mean by unique? You don't have two different elements or atoms carrying the same number of protons. So we say the number of protons gives you what? The atomic number. And the atomic number is the number unique to that particular element. Somebody asks you what is the atomic number? The atomic number is the number of protons that the atom has. Everybody got that? Now neutrons have no charge. But if you have an element, a piece of an element, when you examine all the atoms, you'll find that not all the atoms have the same amount of neutrons. They vary. And they're usually isotopes of each other. So the number of neutrons may vary in an atom, which causes it to become an isotope. But if the number of protons become different, then you have a different element. Yes.
What makes up the mass?
Number of protons plus the number of neutrons. Okay. And these are found, the combination is found in the nucleus. Combination, why are you refracting?
Yeah. You know what? See, that ain't right. I gotta get here. You say 2:45.
22:45. If you're talking in military time, that would be
45.
10:45 in the night.
Oh, man.
Military time this now will be 14:44. Okay. Have to correction that one.
He said 2:45.
Huh? I can't get it out. You know to do that? This actually tells me it prompts me to change it to the next slide, that's all. Okay. Now Miss Monica set it up. Just started. We're starting, we're talking about the atom. And we say that the atom has a nucleus. And in this nucleus you have what? The protons and the neutrons. The protons and the neutrons comprise what? The mass number. Right? And the number of protons tell you the atomic number, right? How many of you here had chemistry? So it should be strange to you guys. Review for me. This is just even less than elementary chemistry.
Yeah, no.
Okay, it is less than elementary chemistry. For those people who never had chemistry, it's a bridge to them. Okay. Now if you're going into BS nursing or any advanced science degree, that's chemistry. Chemistry is reported as math and science. So this is just basic, I'm just laying out the foundation. Have you noticed that this course is biology, but you have to do chemistry? You can't get away from math, chemistry. Any type of the science, you have to do chemistry. You can't get away from it. Just like math. You can't get away from math. Anything you do, you have math. Okay, let's continue. So the number of protons gives you the atomic number. Well, you got that? And the protons and the neutrons comprise the mass number. Now just flip back to the nucleus of a living cell. And we say the nucleus of a living cell has what? DNA, the genetic material. Now we talk about elements. Elements are made up of atoms. What we just been talking about. The smallest part of the element. Each element is represented by a chemical symbol. The symbol represents the element's name in English or Latin. Now, this is what I've been saying. The number of protons is unique for each element. This is called the atomic number. In a normal atom, the number of electrons and the number of protons are the same. Now, elements combine to form molecules or compounds. And this is where you need to be able to differentiate between a compound and an element and a mixture. What's the difference? A compound has two or more elements chemically combined. Okay. Now, we have a list of the different types of elements in the body, the common types of elements in living systems. Our body is nothing but a set of chemicals. You name all the elements. We have iron in our body, we have lead, we have all, even in trace. Even some of them, do you know your body, you need some arsenic, so it's a poison. Very minute, minuscule amounts. That's right. It's poisonous, but in very minute amounts. So you don't go drinking arsenic, you get it automatically in some foods that you eat. Now if you look at your condensed at page 2-5, the common elements in the body, the living system. Hydrogen, carbon, nitrogen, oxygen, phosphorus, calcium, sulfur, sodium, potassium, iron. Now is salt an element?
Mm-hmm.
Yes.
Yes, sodium.
It's a compound.
It's a compound.
But
Mhm.
it's separate.
You have to think now, don't go and write an examination by the decide. Salt is a compound made up of sodium and chlorine. The compound has two or more elements chemically combined. So when you say salt is a common element in the body, no. Maybe a common compound in the body, not an element. How about sugar? Is it a common element in the body?
No.
No. Maybe a common compound. The sugar is made up of what? Carbon, hydrogen, and oxygen. Anytime it's made up of more than one element, it's no longer an element, it's a compound. Right?
Sugar is a common compound in the
This number
body.
here always tells you how many what is in this element. Proton. In other words, it's telling you what is this telling you. Atomic number. This number here tells you what? Mass number. And the mass number is situated in the nucleus of the atom.
What's the difference? What's the mixture? Because on the test you said that know the difference.
The mixture is something that's physically combined. You can easily separate it out. In a compound, you cannot separate the constituents out very easily.
You say it's easily.
Typical mixtures like salt and sand. If you want to separate out them, you just put them in some water. The salt is going to dissolve out. You filter it, you get all your salt, water, and you get your sand settling. The sand is not going to dissolve. You make use of the different solubilities. Okay. Now the outermost shell of the electron determine the chemical properties of the element. Now electrons can hold, there are different shells. You have first, second, third, and fourth. Now in this course we're not going to deal with so many shells. We have what you call the octet rule. The octet rule is so called because no matter how much the outer shell can hold, it is not happy. Put it simply, it's not happy or satisfied if it does not have 8. That's the octet rule. Atoms are in their most stable form when the outermost shell holds 8 electrons. And this is why elements combine, they have reactions. They're striving to stabilize their outer shell. And we talk about 2 types of bonding. When the elements combine, they form a bond. There are 2 types of bonding. You have the ionic bond, sodium and chlorine, right? The ionic bond, you have a separation of
Electrons.
You have a
transfer
of electrons. Okay? Ionic bonds, and they are not strong. You separate out in water very, very quickly. Like ionic bonding of atom, sodium. The sodium has an extra atom up here. It wants to have 8. So if it removes this one, it's going to have 8 here. So what it does, it comes with chlorine, which needs 1 to complete its shell. So the 1 goes to the chlorine, and so this becomes positive because it has now more what? More protons than electrons. You lose an electron and you have the net charge of positive. Now this one is going to gain an electron, so it has more electrons and protons become negative. And because they become charged, they then turn back and become attracted to each other and form a compound. Covalent bonds form when the atoms share electrons. And they usually share them in the outer shell. And we have a special covalent bond in water. What do we call that? Polar covalent bond. Why do we call it a polar covalent bond? Because it has a positive and negative end on that structure. See? This one comes and shares this one, the sole electrons here. This one comes and shares sole electron here. So they now have, that's why you have H2, 2 H's, H2O. And this is how they've gone, HOH. This area is strongly positive, this area is strongly negative. 2 hydrogen, 1 oxygen. Water, polar covalent bond. So non-polar are the ones that are shared equally between atoms. Polar bonds, the electrons are shared unequally. So water is an example of polar covalent bond. Always remember that. Now we move on to organic compounds. An organic compound is one which has what? Carbon bonded with oxygen, with hydrogen. All organic compounds have the skeleton of covalently bonded carbon atoms. Carbon atoms form very stable. Covalent bonds form very stable bonds with each other. Okay? Now, we are studying molecules of life. Well, let's briefly talk about water before we go on. Now, all living things are comprised of organic compounds, right? They're built from organic compounds, basically. That's why we're so well put together. We do not lose something. There's a strong bond. However, there's an irony. What's the most abundant compound in our body?
Water.
Water.
Which is inorganic.
But water is not organic. Water is inorganic. Why? Because it does not have any carbon. Another thing about unique about water is inorganic. Oh yeah, it's made up of polar covalent bonds. Usually organic compounds are made up, only organic compounds are made up of covalent bonds, but it has a polar covalent bond. So you have to note that. Now, we're studying the molecules of life, and there are 4 classes. Right? And each molecule of life has a large molecule, made up of large molecules of smaller building blocks. And these smaller building blocks are called monomers. The larger molecule is called a polymer. Now, polymers may consist of thousands of covalently bonded units. Okay? For instance, look at the polymers of carbohydrates. Polymers of carbohydrates are what?
Cellulose and glycogen.
Starch, glycogen, cellulose. These are all polymers. These are large molecules. Okay? Now, starch, glycogen, and cellulose, they're all made up of units of sugar. And if you want to build them from scratch, from the monomers, you have what we call, what sort of reaction will that be? You want to build them from scratch, from the monomers. You take, for instance,
Peptide?
let's build a disaccharide. Let's say we want to build the disaccharide lactose. So what monomers are we going to use to build lactose?
Lactose, glucose, and galactide.
One glucose unit
Glucose.
plus what?
Galactide.
Galactose.
Galactose.
Okay? And that's going to produce the sugar in milk called lactose.
Galactose.
Now, what sort of reaction is this? We mentioned 2 types of reaction, one in which water is lost and one in which water is gained.
Oh, hydration.
Water lost here or gained?
Dehydration and...
The question is, is water lost or gained?
Lost.
Lost. Anytime you're adding, you're losing. Paradoxical, right? To build, you lose. To break, you gain. Right? Put that down on the board. So that you will get some So this is called dehydration. Synthesis. Right? Now if I were to flip it around and get some, say you drink the milk and then the body is breaking down the lactose, because it has to be broken down in order for it to be absorbed. Any macromolecule taken in the mouth has to be broken down into its monomers before it's absorbed into the system. It has to get small enough to pass through those little pores in the small intestine. So they have to become the smallest unit.
You can't do that with polymers?
Polymers cannot be absorbed into your system directly. That's why you have to have your food has to be digested. And the being digested is broken down into the smallest units. You take the large molecules in your mouth and it's taken apart as you go down, as it goes down. Start first here, proteins here, first here, and then lipids start and finish here, and finally everything is broken down into the smallest units in the intestine. Then it's absorbed. So monomers here, macromolecules, polymers here, monomers here. Got that? And in order for the monomers, the polymers to break down into monomers, you must do what? Add what?
Water.
So if we were to flip this around and look at lactose, and let's say we drink some milk, we have the milk sugar. The body has to break this down into glucose and galactose. Glucose plus galactose. What sort of reaction is this?
Hydrolysis.
Hydrolysis. Water has to be added. H2O. Water has to be taken away here. Remember that. Hydrolysis. That's why I say you drink a cup of water before you eat. A glass of water. Remember, I told you how much water is spewed into the alimentary tract every day? How much?
7 liters.
7 liters. How much of this is reabsorbed?
90%.
90%. Where most of it is absorbed?
The colon.
Colon. What's the other word for colon?
Large intestine.
Large intestine.
That's how less work. Glucose.
Yeah, glucose.
Okay? Now this is no rocket science. All you have to go home and go over your notes. Number one, if you take good notes.
Last one.
Number two,
Lactase
when you go
equals
home and you
glucose
read your
plus
notes, you can understand it. Number three, understanding it. Number four is when you're in the exam. Figuring it out. Okay. Now, if you're diabetic, right? What are the precautions? Well, how would you take care of yourself as a diabetic? You're under doctor's care, but there are certain things individually you have to do. What are these things?
Watch your sugar intake.
Exercise. How about your diet? Stay away from what?
Sugars.
Refined carbohydrates and saturated fats. Okay. Exercise, diet, stay away from these things.
Water.
Very important.
Jeez.
What else can you do?
Take insulin.
Watch your weight. Keep your weight down. Okay. Now we talk about the pH. I won't go in as to why the lower the number, we already did that. The lower the number, the what?
Acidic.
The higher the acidic level.
The higher, the more concentrated the acid is. Okay? The higher the numerical number, the more you have what? Of hydrogen ions. The pH scale runs from what? 0 to what?
14.
14. And this is the neutral part.
7 or something.
most basic, this is the most acid. So we have from 1, 2, 3, 4, 5, 6, 7, 8. 6, 7, 8. As you get above 7, it becomes alkaline or basic. Now your body maintains its pH by what? What does it use? To maintain, to keep the pH into balance.
Buffers.
Buffer system. If the pH starts to get lower, gets more acid, it adds more hydroxyl ions, brings it up. Okay?
Hydroxylion.
Simple, simple.
OH ions, hydroxyl, OH.
To maintain the pH level.
Now,
Body uses buffers to maintain the
let's
pH
talk
level.
about the next set of compounds, lipids. Finish carbohydrates. Now, lipids, we all know about the saturated
Buffer.
and
Buffer system.
unsaturated fats.
Yes, it
Good
buffers.
ones are the,
Unsaturated.
and that means they have what? What sort of bonds between the carbon atoms?
Double bond.
Double bonds. These are mostly in plant products. Now, I mentioned to you that in industry and in food selling industry, the convenience, they convert these double bonds into single bonds. And how do they do that?
By adding hydrogen to it.
So if this is an oil, when you add hydrogen, what becomes what? It becomes a solid fat. Most solid fats are single bonds. Okay. So so hydrogenation means adding hydrogen that reduces these, convert these double bonds to single bonds. Okay. That's bad for you. Is there any question here? Now, the lipids are usually, they have several functions. Now, we give fat a bad name. Our fat is very important in our body. It insulates us. What else does it do?
Stores energy.
Energy storage. Now, there are different types of lipids. We have one type of lipid that's important in the membrane of the cell. What's the name of that lipid?
Steroid.
Phosphate lipids.
Lipid that's found in the membrane of plant
Phosphate
and animal
lipids.
cells.
Phosphate lipids. Phosphate lipids.
Phospholipids. Phospholipids.
You didn't hear me.
Doesn't membrane.
Where is it? In the where?
Phospholipid.
It's in the membrane.
Phospholipids.
Yeah, membrane.
Also part of the plant and animal cell. And somebody was telling me what ER. Now, lipids. Now, the cell is a little factory, manufactures stuff. Okay. All the lipids are manufactured in what part of the cell?
Smoothie, right?
All the lipids are manufactured in what part of the cell?
Smoothie.
What organelle?
ER.
Smooth endoplasmic reticulum. Anything that's steroid, corticosteroid, cholesterol, anything that's fat-like is manufactured in the smooth area. I swear. You gotta kill me in this place.
Cells.
I think you were actually the only one who came from the other class. No one else showed up.
I like the way he speaks. I swear.
Yeah, like he's gonna beat him up.
Come on, get it.
Oh, I need one too.
You have it.
I can't believe it.
Hey, Emmanuel, you have one.
You guys will eat it?
Emmanuel,
Oh, I don't have one.
you don't have this? He gave it to us. You have it.
No, that's not. I'm talking about the. I thought it was the Nina.
This is that, right?
Number one.
No, I thought it was the.
Everybody has it, right?
System.
Yeah, I remember he gave it to
This
us.
from yesterday?
All you guys need study guides? I don't believe it.
That's the same one as you. Let me see.
They move like sheep, son. Swan them like sheep.
No, I don't have
You guys, what are you guys doing with these study guides? I swear it's something you got before.
I don't have
Oh, he gave it to him.
No, no, but there's no more to give out. There's no more here. I knew everybody.